Hi, in this video we're going to have a look at Dijkstra's algorithm, and we're going to have a look at how we can apply it to this network to try and find the shortest distance from A to G. So to start with, we're going to just label the vertex A with a 0. That's where we're starting, and it's 0, let's say miles, it doesn't really matter, but 0 miles to get from A to A. And now from A, we're going to look at each of the vertices that are connected directly to A. So we've got vertex B, which is 9 miles away from A to B, vertex C, which is 3 miles away, and vertex E, which is going to be 14 away. Okay, so now of these, the shortest one is going to be 3, and I'm just going to draw a box around that number 3. So what we're saying here now is C is definitely 3 away from A. Okay, that's definitely the shortest distance to get from A to C. No other route is going to be as small as 3, so that's definitely the shortest. Okay, now from this point 3, I'm just going to update any of the other values that are connected to C. So C to B, well, that's 3 and another 5 is 8. Now that's actually going to be less than the direct 9 from A to B. So we're going to update that value with the number 8. And when I'm doing this algorithm, I'm just putting a single line through that 9 so I can still see that it's there, but I'm updating it to the value 8. And that shows that I'm following the algorithm. Okay, from C to D, well that's going to be 3 and 16, which is 19. So that's a new value to D. And then C to E, well at the moment it's 3 and we add 9 and that's going to be 12, which is shorter than the direct path from A to E. So I'm going to update that value 14 to 12. Okay, now with my new values I'm now going to select the lowest of those values. So the lowest of those values is 8. So that means that A to B, the shortest way I can do it is definitely 8. There's not going to be a shorter route there, and that's going via C and B. Okay, so now from 8, I'm going to look at all of my connected values. I don't need to look at B to C because I already know that's the shortest value there. B to D, that's another 12. 8 and 12 makes 20, and that's not less than 19. And there's no other connections to B, so I can move on to my next lowest value, which is going to be 12. So A to E, the shortest path from A to E is definitely going to be 12. Okay, so we'll look at all the other connected values to that E. Well, E to D is 18, 12 and 18 is 30, that's not going to be less than 19. E to F is 18, that's a new value. Sorry, A to F is 18, so that's a new value. And that they're all the connections from E, so now I'm going to have a look at these two values, and of those 18 is the lowest, so I'm going to box 18. Okay, so following the algorithm again, F to D, well that's 14, 18 and 14 is going to be 32, that's not going to be less. 18 and 17, that's going to be 35, so I'll label that there, 35. Okay, and those are all the connections, so the next lowest value is going to be 19. Okay, so 19 and 12, that's actually going to be 31, so that's less than 35. I'll cross the 35 out and put a 31 next to it. And that's my final value, so I can put a box around that, and that tells me that the shortest distance from A to G is definitely 31. Now along the way I also know that the shortest distance from A to D, for example, is 19, and A to F is 18, etc. Okay, so now what I'm looking for is I want to write down the actual path to get from A to G. So if I start with this 31, and I'm going to work backwards through my network. So 31, take away 17. Now that's not 18, so I don't think it was this path I came down. It must have been this one. 13 take away 12 is 19. So So I finished with G, and before that I must have come from D. So from D now, I want to find the path that I came from, so I'm just subtracting all the edges one at a time, and it looks like I came from this path here, which is at C. 19 take away 16 is 3. So I could put a C over here, and then finally that must have come from A. So my shortest path is going to be ACDG. ACDG. That's going to be the shortest the shortest path from A to G. And the shortest distance is going to be 31. Okay, thanks very much for joining me. I'll see you next time.